Space technology is technology developed by space science or the aerospace industry for use in spaceflight, satellites, or space exploration. Space technology includes spacecraft, satellites, space stations, and support infrastructure, equipment and procedures. There is an automated motor vehicle called the Mars rover that propels itself across the surface of the planet Mars upon arrival. Rovers can place themselves in sunny positions to weather winter months, and they can advance the knowledge of how to perform very remote robotic vehicle control. One of the biggest criticisms against space exploration is the cost. According to the University of Florida, it costs around $500 million to launch a space shuttle. There are always problems with unforeseen risks with space exploration. There was the Space Shuttle Challenger that exploded during the launch in 1986, which killed 7 astronauts.
Days than NASA cares to count. This morning it looked as though they were not going to be able to get off.
1 minute 15 seconds, velocity 2,900 feet per second, altitude 9 nautical miles, downrange distance 7 nautical miles.
So there was a shuttle tragedy, and 7 people died. And that's terrible, but a lot of people die all the time. But why do we care so much? Because it was the dream of exploration that was dying along with those people.
So we have the CEO of Tesla and SpaceX on the line here. I'd just like to ask you a few questions about SpaceX. Basically, what thrives you when you do something? What is it exactly that thrives you?
I think the thing that drives me is that I want to be able to think about the future and feel good about that. We're doing what we can to have the future be as good as possible, to be inspired by what is likely to happen, and to look forward to the next day.
So what is your vision?
I think, particularly for Americans, think about America is a nation of explorers. People came here from other parts of the world that, chose to give up the known in favor of the unknown. So I think exploration, I think the United States is a distillation of the human spirit of exploration.
So what is SpaceX about in your mind?
SpaceX is about helping make life multiplanetary. And doing what we can to continue the dream of Apollo, and ultimately make a contribution to life becoming multiplanetary.
NASA is developing a whole host of technologies that will enable them to get humans and spacecraft on the surface of Mars. So when we talk about going to Mars, we can break it down into a couple segments. They have to get to Mars, they have to land on Mars, they have to live on Mars, and then they have to leave Mars. One of the biggest challenges is landing on Mars. The Mars Curiosity rover landed on Mars. They know they have to get more people, more cargo to the surface. But one of the biggest tests they just did off the coast of Hawaii is what some people call NASA's flying saucer. They took up to Mach 4 at 180,000 feet and deployed new ways to slow down, a supersonic parachute, and an inflatable structure. And that is some of the technologies that they're working on to get us to Mars. They will get us to Mars in a series of steps. First and foremost is to use the International Space Station to practice, develop, learn how do we live, how do we thrive in space. From there we can go to the proving ground, above low Earth orbit, to the Moon. And there they can enable our ability to navigate, communicate, propulsion and life support systems in a stepping stone approach to get to Mars. To be human is to be an explorer. It is part of who we are, since the first tribes left the African savanna and spread into Europe and Asia. We have always had the need to explore the unknown. Now humans have visited or settled every corner of the globe. This instinct to explore is still active, but there are very few outlets. Some people seek out extreme or exotic places to satisfy this need, risking their lives to do so. Others look to the skies. It may be an old cliche, but Star Trek had it right. Space is the final frontier, and it calls to the explorer in all of us. As it stands, all of humanity's eggs are in one small basket called Earth. It is only a matter of time before something happens to our planet that is so devastating that it changes the course of life as we know it. Whether the disaster is natural, like a rogue comet, or a self-inflicted, like nuclear war, it is possible that our home will no longer be habitable. What happens then to all of our accomplishments of the last 1,000 generations of humans? All of our art, our music, our literature, our science, even our very genes could be wiped out. Unless, of course, there are few humans living elsewhere in the solar system. Space exploration and colonization of the Moon and Mars are our insurance policy for humanity and all of our achievements. The word rocket can mean different things. Most people think of a tall, thin, round vehicle. They think of a rocket that launches into space. The word can also mean a vehicle that uses an engine. But how will rockets change in the future? The new rockets are being developed today. They will launch astronauts on future missions. The new rockets will not look like the space shuttle. These rockets will look more like earlier ones. They will be tall and round and thin. They will take astronauts into space. They will take supplies to the International Space Station. NASA also is working on a powerful new rocket called a heavy lift vehicle. This rocket will be able to take big loads into space.
Earth, a planet where life has existed for more than 100 million years. Our planet itself is well over 1 billion years old. Everything we know that has existed on this giant big blue planet that we call home. So far, Earth is the only known planet in the whole entire universe that harbors life. Until recently, that is. In the last 2 decades, we have discovered thousands of other planets way beyond our solar system, otherwise known as exoplanets. These planets come in different sizes, colors, environments that make each of them unique. For example, Kepler-16b, a planet which has not one, but 2 host stars. The Kepler star system is the only star system that has more than 1 star. This sort of outcome is only possible in movies such as Star Wars. However though, touching foot on the surface of this planet will instantly turn you into ash due to the high temperatures. Or what about planet 189773b? Average temperatures on this planet can reach up to 1,706 degrees Fahrenheit, with winds of up to 5,405 miles per hour, which is equal to 8,700 kilometers per hour. The atmosphere of this planet contains silicon particles, so adding them all together results in glass being rained down from the sky. A similar planet to this is Corot 7b. This planet is tidally locked, which means it never rotates. Just like the moon never rotates and we only see one side of it. This results in two different effects on each side. For example, temperatures on the hot side can reach up to 4,700 degrees, while on the cooler side it will be 2,600. Rock is melted into molten lava and then evaporated into air. On the hotter side it comes down as molten magma. However, on the cooler side it is cooled down and it starts raining rocks. Although these planets are incredible, the whole purpose of finding other planets was to find a planet like Earth. Because one day in the future there will come a time where we need to move to another planet, whether it be overpopulation, nuclear war, and so on. Out of all the planets we've discovered, which is well over 10,000, only 4 of them seem compatible to support life. But the problem is that they are well over 200 light years away, which means even if we do find a way to travel at the speed of light, which is impossible, we will still need to travel for 200 years, non-stop. So what makes a planet habitable? Well, it needs to be the perfect distance away from the sun. Too close and the water on the planet will boil. Too far and the water will freeze. In the middle, or otherwise known as the habitable zone, is where life can exist. Earth is the perfect distance away from the sun for liquid water. Which brings us to the next factor. Water and oxygen both need to be present for life to exist. Which is why the Mars missions took so long to organize. We needed to find a way to find oxygen, water, and food. More importantly, how we're supposed to rest and take shelter. So back to the 4 exoplanets that are capable of supporting life. 3 of these planets are in the exact same star system, known as the TRAPPIST system. All 3 of them are in the Goldilocks zone, but unfortunately all 3 of them have unique problems. The first one, TRAPPIST-B, although it is in the habitable zone, it is tidally locked, resulting in one side being extremely hot while the other one is extremely cold. So somewhere in the middle would be the most suitable conditions for us. The second one, TRAPPIST-D, is a perfect temperature and contains water. However, most of the water is underground or either frozen, which also means that this planet does contain oxygen, but is all just trapped underneath. The third one is still a mystery. All we know is that it might contain water and is still located in the habitable zone. The whole entire TRAPPIST system is approximately 146 light years away, which is still extremely far away even if we do consider traveling to it. Which brings us to the final planet, Kepler-22b. It ticks all the boxes. It contains liquid water, oxygen, and the right temperature. It even has land. It also has 80% of Earth's gravity. Kepler-22b is almost an exact replica of Earth. If anything, life may already be existent on this planet. So what's the problem, you may ask? Well, that's because this planet and its whole entire star system is well over 500 light years away. We're not even 100% sure what the actual surface of the planet would feel like. The techniques we use to find exoplanets is called transit photometry. A satellite called the Kepler satellite was released in 2012. It uses the method called transit photometry to find exoplanets. Transit photometry is when a planet goes across its star and in front of the telescope, a tiny dip in light is recorded. When a dip in light is recorded consistently, then we know we have discovered a new planet. The bigger the dip, the bigger the planet. So I managed to get a phone interview with a Kepler scientist called Martin Still. This is what he had to say about Kepler 22b.
So what do you think about Kepler 22b? Do you think life could exist on it?
Habitable zones where it's possible to have cooling water on the surface of the planet. Now it's possible, doesn't mean it is there, it means that it's not ruled out. And so, it's not definite. This is a habitable planet. This is a planet in the habitable zone where, temperatures are possibly conducive to the evolution of biology. So that's the discovery. There are lots of challenges ahead. If biology wanted to find a home there, it would have to meet a whole bunch of criteria. So, for instance, the temperature is actually quite cold. Without an atmosphere, it would be cold enough, so cold that the water would not actually liquefy, solid water would be icy. But if it did have an atmosphere, just like we have greenhouse effect on the Earth, that atmosphere would actually warm the planet, and then we'll get into that zone between frozen water and boiling water, where you expect water, like an ocean or a lake or a river, to form. Unfortunately, we don't know whether that atmosphere exists, right? We can't measure that right now. There's no measurement object. We can only guess. We don't know. If it does exist, it also has to survive tremendous violent environment, because the star lit orbits flares, much more so than the sun, and those flares would try and evaporate that atmosphere, and try and evaporate it to the place of the surface, escape into space. Now what could save a planet like that disastrous escape is if it had a magnetic field, just like the Earth has one. Our magnetic field protects us from one.
Unfortunately, his phone died, but what he's trying to say is Kepler 22b has a high chance of supporting life. And so here ends my talk about exoplanets. Maybe in a century's time, we may already have taken over another planet, or maybe we're still stuck in Earth. Or maybe we even made contact with an extraterrestrial life form, which is what you will learn next.
All you need to make a star is hydrogen, gravity, and time. Gravity pulls the dust and gas into a giant swirling vortex. Gravity brings matter together, and when you bring gravity together, and when you bring matter together and squeeze things into smaller spaces, it will heat up. Over hundreds and thousands of years, the cloud gets thicker and forms a giant spinning disk that is bigger than our own solar system. At its center, gravity crushes the gas into a super hot dense ball. Pressure builds until huge jets of gas come out of the center. Jets that are many light years across. Gravity keeps the pressure on, sucking in dust and gas particles that smash into each other, generating more and more heat. Over the next 500,000 years, the young star gets smaller, brighter and hotter. Temperature at its core reached over 15 million degrees. Only at that temperature can atoms of gas begin to fuse together, releasing huge amounts of energy. And then a star is born. So, how long do stars live, Dr. Kyle?
A star's life expectancy depends on its mass. Most of the time, the bigger the star, the faster it burns up its fuel supply and the shorter its life. The most massive stars can burn out and explode in a supernova after only a few million years of fusion. A star with a mass like the Sun can continue fusing hydrogen for about 10 billion years. And if the star is very small, with a mass only a tenth that of the Sun, it can keep fusing hydrogen for up to 1 trillion years, longer than the current age of the universe.
So, what different types of stars are out there?
There are 5 main different stars. First off are red giant stars. Red giant stars are stars that are going to die, and they can reach 100 times bigger than the original size of that star. Someday our sun will become a red giant. White dwarfs are the corpse of a star. White dwarfs cool out to become a dense floating black ball in space at some point. But that has not happened yet because the universe is so young. It will take hundreds of billions of years. Red dwarf stars are the smallest stars and the most common in our universe, most being 0.075 times the size of the Sun. Neutron stars are the next biggest type of star, and they can be 1.35 to 2 times bigger than our Sun. Finally, there are supergiants. Supergiants live short lives since they are unstable and will explode as a supernova someday. The biggest star in the universe is Uariscutai, which is 2.4 billion kilometers long, and the volume is 5 billion times that of our Sun.
How is the life different between a small and a large star?
Smaller stars live different lives because they are stable. A small star survives until all of the hydrogen turns to helium, so about 10 billion years. They are cooler and shine less brightly. By this point, it has become a red giant. Larger stars live shorter lives because they are unstable and very violent on themselves. In the next million years, a series of nuclear reactions occur forming different elements in shells around the iron core. As soon as a star starts to create iron, it will be its demise.
Just like Dr. Kyle said, smaller stars and larger stars have different lives, as well as different deaths. Once a red giant has ceased to live on, it will turn into a white dwarf with about 50% of the original star's mass. The white dwarf is also the same size as Earth, and once it runs out of heat after billions of years, it will become a dark black ball known as a black dwarf. The gravity is strong enough to instantly crush and kill you if you attempt to land on it. Larger stars will blow up in a supernova, which glows brighter than the universe for a short time, and then turns into a black hole. A supernova will completely vaporize planets close to the explosion. Smaller stars like our Sun will become a red giant and become 100 times bigger than it currently is. It will swallow the Earth or go almost as big as Earth's orbit. Venus and Mercury are completely devoured by this point, and Earth is either gone or a molten lava rock.
Are you afraid of me? Well then, let's get started. What are you doing here? Research who? Us? Or the planet, or what? Why do you need to research us if obviously you're more intelligent than us because you're able to get here? Yeah, on that thought, how did you get here as well?
I've been straight that cost all for about 20 years. We trying to find back into the life. I came from a galaxy you guys all call, and they say 1300.
Yes, but how did you come from there all the way to the Milky Way galaxy and then to our solar system? Tell us more about this teleportation. Tell me now, or I will kill you. How long have you been researching us? Where does your species sit on the Kashtev scale? How old are you guys, and how old do you guys normally live for?
491 Pascal. But I've been living to about 1920.
How do you guys live for so long? Put him in the X-ray now. Let us have a look at him.
This will be good for our species. The observable universe is around 90 billion light years in diameter, approximately 100 billion galaxies within it, each with over 100 billion stars, all with millions upon trillions of possible habitable planets, but everything past our so-called local group we will never be able to reach. This is because of the expansion of the universe, which will make the journey take billions of years, even if we travel at the speed of light. Our Milky Way galaxy has around 400 billion stars and 20 billion sun-like stars. If we believe only 1/5 of those have a planet in the habitable zone, if only 0.01% of those planets had created life, then there would be 100,000 planets with life. Now, the Kashtev scale places the intelligence of life in 3 categories. Type 1, category that is able to access all the energy on their planet. We are around 0.73 on the scale. Type 2 would be able to harness all the energy from the sun. Type 3 is a civilization that would be able to control the entire galaxy and every single planet and star around it. The Fermi paradox, the stage 3 of extraterrestrial life being alive. We could say that it is impossible, but we have no idea. Our species is a couple of million of years old, and we haven't even found anything, and we haven't even sent us anything. Only life in the universe, it is almost impossible. Mathematically, it seems that it is. Frank Drake created the Drake equation to give humans an idea of how many detectable civilizations there are in the universe. N equals R times F times N times F times F times F times L. N means the number of detectable civilizations. R means the average rate of the star formation. Fp equals the fraction of formed stars that have planets. Ne is the number of planets with environment that could support life. Fe equals the fraction of those planets where life appears. Fi equals the fraction of planets where intelligent life emerges. Fc equals the fraction of civilizations with technology that releases detectable signs into space. L equals the length of time the civilization releases 90 billion light years of space, and we are the only people. It just isn't believable. We may be the only living organism in our Milky Way, but that is still very unlikely. There are billions of other galaxies we have no idea about. We haven't even started studying them. If we were to find extraterrestrial life, we would have to look through the entire universe. So far, we have found or researched 3% of the visible universe. 3%. Most people believe that extraterrestrial life exists, but it isn't as intelligent as us. People say that in Area 51 of the United States of America, the government keeps unknown objects and living organisms from other planets there. See, us humans create conspiracies because we have no idea, but at the same time we're scared. And people like the suspiciousness of the not knowing what's going on.